Good morning, girls. Children, we started the chapter Gravitation in the last week, and I had discussed with you what is the force of gravity, gravitational force. Then I also gave you some examples to understand how this force of gravity work on different objects. Like if he throws anything in the upward direction, suppose a pen or a chalk, or any other thing like a ball, then it falls down in the downward direction, and this is because of the presence of the gravity on the surface of the earth. Now the force of gravity does not only exist on the earth's surface, it exists in fact everywhere in the universe, okay? And the examples which show that the gravitational force exists everywhere is the existence of solar system and the motion of the planets, motion of the satellites around the planets. So these are some examples which show that the force of gravity is present everywhere. Then I had told you what is the Newton's law of gravitation. The Newton's law of gravitation says that every object in the universe attracts every other object by a force which is directly proportional to the product of the masses and is inversely proportional to the square of the distance between them. Then why is this Newton's law of gravitation also called the universal law of gravitation? I also told you. Then we also discuss some important points or importance of this gravitational law, that is the Newton's law of gravitation. Now you know that the formula for capital F is, the force of attraction is F is equal to G m1 m2 upon d square. Yes, now capital G is, capital F means the force of attraction between any two objects. Capital G is a gravitational constant which is having a numerical value, that is 6.673 into 10 to the power of minus 11 Newton meter square per kg square. Now, the two factors on which the capital F, that is the force of attraction, depends are, the two factors are, number one is it depends on the product of the masses and it is inversely proportional to the square of the distance between the two objects. Now today I will discuss with you some questions or some numericals based on this formula, that is F is equal to G m1 m2 upon d square. Now you know that if the masses of the two objects increases, the force of attraction between them will also increase, and if the distance between the two objects will increase, the force of attraction between them will decrease, and if the distance between the two objects decreases, then the force of attraction between them increases. So we have, suppose, a question I'll take up first, that you know this formula, now you know this value, and I also told you that if there is this capital G to be used in the question, you can only use 6.7 into 10 to the power of minus 11. And why I told you, because it will make your calculations little simple. So there's a question given in your book which is on page number 134. So children, when you will see this video, you can go through the question. I will read it for you. That the mass of the earth is 6 into 10 to the power of 24 kg, and the mass of the moon is 7.4 into 10 to the power of 22 kg. So we have m1, which is 6 into 10 to the power of 24 kg. Okay, if you want, we can write me, which means mass of the earth, and mm means the mass of the moon, which is 7.4 into 10 to the power of 22 kg. Now, the distance between these objects, earth and moon, is given by 3.84 into 10 to the power of 5 kilometer. Okay, it is in kilometer, remember this. Then you have to find the force. You have to find the force of attraction between these two objects, that is the earth and the moon. We normally write m1 and m2. If you want, you can write m1 and m2. If you want to write me and mm, that is also correct. Now you know the capital G is equal to 6.673 They have given 6.7 into 10 to the power of minus 11 Newton meter square per kg square. This is given on page number 134. Now we have to find the force of attraction between the earth and the moon, and you know the formula is F is equal to G M E M M upon D square. Now you have all these values in raised to the power of 10 raised to the power of, and so you have to be, you have to understand the method of solving this type of numerical, these type of values. So what we'll do, we will first convert kilometer into meter, you know, because the standard unit or the SI unit will be in meters, and therefore we will multiply 10 to the power of 5 into what? Because 1 kilometer has 1000 meter, so I will multiply into 1000. That means I can multiply by 10 to the power of 3. Okay, so that means the distance between the two objects will now become 3.84 into 10 to the power of 8 meters. Okay, now we will apply these values in the question, in the formula. So F is equal to, okay, I hope you can see, F is equal to G, that is 6.7 into 10 to the power of minus 11. Then ME means 6 into 10 to the power of 24 into 7.4 into 10 to the power of 22 upon D square, that means 3.84 into 10 to the power of 8 the whole square. Now it is not easy to solve these entire values, so we have to separate them, and what we can do, we will first take all the numerical, that is these numbers separately, and the 10 with the powers, we'll combine them and write them together and then solve it. So we will now see that F is equal to, I will write 6.7 into 6, okay, into 7.4 upon 3.8 into 3.84, this is also 84, 84, yes, yeah, and into, now here it is 10 to the power of minus 11 plus 24, you know, when the bases are same we add the powers, and plus 22 minus 10 to the power of, this will be 16, so minus 16. Okay, so you understood what I have done? Combine all these numbers, and 10 to the power of minus 11, 24, 22, minus 16. So what we'll do, we will first check out what is 24 and 22. 24 and 22 is 46. What is 11 and 16? 11 and 16 is 27. So we will subtract 46 and 27. So you will get here, this will be 9 and this will be 19. So now I am rubbing this because this is all given in the book. So we now, what do we do now? We F is equal to, as I told you, the page is 134. Now 6.7 into 6 into 7.4. Here I write 10 to the power of 19 after the calculations, and upon, okay, now you know what is upon. Upon is 3.84 into 3.84. Now I can remove this decimal by 2 places, and here this I can remove by 1 place, and this I remove by 1 place. So total how many? 2 places here and 2 places here. Now if I remove the decimal here by 2 places, I have to put 10 to the power of 2. Okay, so now it will be 10 to the power of 21. Now what you will do, you will solve this entire thing, and I know it is not so easy. So you will first multiply 67 into 6 into 74 and then you can first simplify also, cancel also, and then divide it by 384 and 384, and that will be the answer in newtons. So it will be 67 into 6 into 74 upon 384 into 384 into 10 to the power of 21. Okay, so when you solve this entire thing, as I told you how to do, because if I will do it now, it will take a lot of time. So I told you the complete method how to solve this question. So what you will do, you will multiply 67 and 6 and 74. If you want, you can simplify this. We can take 6 ones are 6 6 are 36. Yes, so 6 ones are 6, 6 6 are 36. Okay, and 2. So 6 4s are 24. So this I have just simplified to 64. Here I can take, suppose I take by 2, then it will be 2 3s are 6 and 2 7s are 14. Here I take 2 1s are 2, 2 9s are 18 and 2 2s are 4. Okay, then we can check out is 67 and 192 can cancel, or 37 and this, what is 37? Okay, so after simplifying, you again do the same thing, multiply 67 and 37 and divide it by 64 into 192. Okay, so that will give you the answer, and that will give you the force of attraction between the earth and the moon. Okay, now similar type of question is given in your exercise. Okay, and that is given on page number 143. So what you will do, children, you will solve question number 3. Now that is your homework. If you don't understand, if you don't get the answer, you can ask me. And question number 16. Okay, so you will solve, you have homework. I've told you the complete method. Your homework is question number page 143 and page 144, question number 3 and question number 16. Means both these questions are based on the formula F is equal to gm1 m2 upon d square. Okay, so see that you solve it carefully, and if you don't get the answer, you can ask me. Now I'll take up one more question, and I told you about this before also, that if the distance between the two objects increases or decreases, then the force of attraction will also change. So let us take up the first question. It says that how does the force of gravitation between the two objects change when the distance between them is reduced to half? Okay, what does this mean? It means that this is question number 1, page 143. Okay, now you have to find the force. No, you don't have to find the force, you only have to find if the distance between the two objects reduces to half, then what happens to the force of attraction. Means does it increase or does it decrease, or if there is no change. Okay, and if it decreases or increases, then how much. So that we have to do. So let us write F is equal to gm1 m2 upon d square. Now it is given that the distance reduces to half. So we will write here in the, as we are going to solve it, we are going to write d is equal to d by 2. That means the distance reduces to half. So now in place of d, we will write d by 2, and the values, m1 and m2 will not change because there is no change in the masses of the object. Now in these type of questions, we don't apply the value of g, we just solve it. So I'll show you how we can do. So f dash, when I put a comma, a comma on f, it becomes, or we say that f dash. If you want, you can give a name f1. Okay, so we will write f dash is equal to gm1 m2 upon d by 2 the whole square. We will not put any value of g. It is only for you to find out how much, what is a change in the force of attraction. Okay, so what we'll do, we will now solve and write gm1 m2 upon, this will be d square upon 4. Now where will this 4 go? 4 will go in the numerator So we will write therefore f dash is equal to 4 g m1 m2 upon d square. Now what is g m1 m2 upon d square? It is f. If you want, you can give it as number 1. So we'll write by equation 1, we can write f dash, okay, is equal to 4f. In place of g m1 m2 upon d square, we can write f, and f is from here. So now we can say the force of attraction increases by 4 times. Okay, what will we write? The force of attraction, the force of attraction between the two objects increases by 4 times. Why 4 times? Because we got the answer f dash is equal to 4f. Don't put the value of capital G. So when you compare this or when you read this, you will come to, or you will say that the force of attraction between the two objects increases by 4 times. Okay, so this is your final answer. So in these type of questions, you will only change either the d or the masses and then compare the two and write in this form. Now similar type of question is given on the next page, page 144, that is question number 6. So in question 6 there are 3 parts. I will do 1 or 2 maybe, then you will be able to understand actually what has to be done. So the next question 6 says that what happens to the force of attraction between the two objects if, now since there are 3 parts, I will tell you, in which it says that the mass of one object doubles. That means over here no change in the distance and no change in the mass of the next, that is a second object. Okay, then in the second part they are asking you that the distance between the object is doubled, then distance between the object is tripled, and the masses of both the objects are doubled. So what I'll do, I will do 1 for you and I will give you the conditions for the second and third and you complete them, and then if you have any questions and queries you can ask me. Okay, so starting with question number 6, page 144. So today you practice all these sums and complete them. So you know that we always start with f is equal to g m1 m2 upon d square. I am doing the first one for you, in which it says the mass of one object is doubled. Okay, so m1 is equal to 2m1. There is no change in m2, there is no change in d. Okay, so we will now write f dash, because the new force will be either f1 or f dash, whatever name you want to give. So f dash is equal to g 2m1, actually it is into m2 upon d square. Okay, so f dash is equal to 2, I bring it in front and write 2 g m1 m2 upon d square. This was equation 1, and from here, I mean this g m1 m2 upon d square, I can now write f dash is equal to 2f. So what is the meaning of this? F dash is equal to 2f. It means that force increases by 2 times. And children, you know that if the mass of the object will increase, the force will also increase. Okay, so this was the first part. So I hope it is clear to you. First write the formula, then see what is the condition given to you. Whatever condition is given, apply that and arrange in such a way that you get g m1 m2 upon d square as it is, and whatever number you have associated with it, you will write in the outside the bracket, and then you compare. When you compare, you will get f dash is equal to 2f, and 2f means the force increases by 2 times. Now I'll give you the conditions for the next 2 questions. You will solve it. So you will have the same procedure, and in the next question it is saying that the distance between the two objects is doubled. Okay, So second part, distance is doubled. Okay, then there is another part in the same second one, distance is tripled. Okay, then in the third, so what you will do in the second cases, in both the cases, there is no change in the mass of the object, there is only change in the distance of distance between the two objects. And in the third case they are saying m is equal to m1 is equal to 2m1, that is the masses are increasing both, and m2 is equal to 2m2. Okay, so now in place of g m1 m2 upon d square, what will you write for the second one? It is 2d the whole square. Okay, and then for this one you will write 3d the whole square, and that 3 will become 9, and then you will compare. Okay, if you get the answer in such a way that f dash is equal to f upon 9, it means that force decreases by 9 times or decreases by 3 times, because if the number is in the denominator, it means the force of attraction is decreasing. And if your answer is like f is equal to 2f or f is equal to 4f, it means the force of attraction is increasing, means it is a multiple and this is a divisor. So when it is a divisor, means the force is going to reduce, and if it is a multiple of f, then it is going to increase. Okay, so I hope this this concept is clear to you. You will complete question number 1, then 3, 1 I have done, so you will complete 1, 3, question number 6, question number 7 and question number 16. So all these questions you complete. If you have any doubts, you can ask me. So I'll repeat the question numbers. Question 1, then question number 3. Okay, you complete these 3, then 6, 7 and 16. These questions you complete in your notebook. If you have any doubts, you can ask me. Okay, so I hope this, whatever I have explained you today, is clear to you. And still, if you have any questions, you can message me and you can ask me. Okay, thank you. Have a good day.